construction is a place that we use the converse of Pythagorean theorem quite often, because in construction what we see is, it's very important sometimes, a lot of the time, that the wall you're building is actually vertical, or that the door frame is actually square. These are kind of important things, because when I build that door frame, it's pretty easy to very accidentally, when I build it, if you ever nail together what you think is a rectangle, a lot of times what happens is it winds up going like this. We get a parallelogram instead of a rectangle. And the door isn't going to close very well if that's the way that your door frame looks. So how do we know that our door frame is square? Well, some people say, well, I could just use my little metal combination square and I could throw that in the corner, and if it lines up, you're going to be close. But the way to really do it is you measure across, you measure to make sure it's a right angle. So you might measure out 3 feet here and up 4 feet here. And then you mark those spots and you measure the diagonal. And that diagonal better be exactly 5 feet. If it's not, you adjust the frame so that it is. I mean, you hold your tape measure up there and you actually push on the frame until that tape measure diagonal is exactly 5 feet. Then you know, because of converse of Pythagorean theorem, that that has to be a right angle. And with bigger walls, sometimes you do 6, 8, 10. In fact, construction workers call that the rule of 6, 8, 10 for right angles. Now, you may not realize when you're doing that, if you're working construction, that you're using the converse of Pythagorean theorem, but you are. Because if that's anything, if it's bigger than 5 feet, if this is too long, that angle is open too wide. It's obtuse. If it's too short, then that angle is acute. You want to get it right on the right angle. So the converse of Pythagorean theorem is very useful. It's something that gets used all the time, every day, by real people doing real jobs. Don't get that a lot in geometry, but every once in a while we run into something like that.
So you're not a real person doing a real job?
Always reading stuff into it. Oh, that's interesting.
I'm so confused.
Don't listen to Michael. You're usually your best. But I have no idea why that just came up.
You click the button.
Which button?
The one down by the camera.
This camera? You guys got a camera on your smartboard?
Okay, that's fun. Okay. We're doing interesting things now.
Why is there so many? Yeah, I've only seen like 6 at one time.
Because I want finer precision.
Yeah, I gotta admit, Mrs. Herbert is like always messed up, and it kind of like made me mad, but I never said anything because I didn't want to be that guy. You know?
Guess so. All right.
That guy. Carol, you know what? You're just
Okay, that's fine.
mean. You just make everyone sad.
There. All right. Good. So that's the kind of thing that we're going to work with. Now today, again, first off, are there any questions on the homework? Anything you want to go over? Okay. Then we're just going to go over a few problems that are review problems in preparation for the quiz. So again, you're going to get a worksheet. Remember, when you get a worksheet and hear a review worksheet, it really is like a practice test. I mean, the worksheet is like got 20 problems on it. You know the quiz is only going to have 10. Guess what? For every 2 problems you see of a type here, you're going to see 1 on the quiz. This is really like the quiz that you're taking. It's just that it's just a worksheet. Tomorrow you'll see basically the same types of questions with different numbers as what you're seeing on the worksheet. So when we give you these review worksheets, if you haven't noticed that before, notice it now. You want to be working hard on these and making sure you understand what's going on and getting the right answers, which are right there too, because that means that you will be doing well on the quiz as well, or hopefully doing well on the quiz if you do well on the worksheet. But these are the types of problems we're going to see. Simplify the radical. Just simplify the radical. So square root of 147. 147 is not a perfect square. What perfect square goes into 147? What's the largest perfect square that goes into 147 evenly? Well, we start by taking half of 147, which would be like 73.5, okay? Now that's not a perfect square, so now I do my perfect squares less than that. 64 is the first one that comes up. Does 64 go evenly into 147? No, because 64 is even, 147 is odd. It's not going to work. So 49. How many times?
3.
Ah. There's my solution. We're done. That's all it takes. Find that largest perfect square. Start by testing half of the number and then working your way back. 4 root 50. Remember, this means 4 times the square root of 50. So it's all multiplication going on here. What perfect square is the largest one that goes into 50? 25. That one's kind of obvious, I hope. Square root of 25 is 5. And 4 times 5 is 20. And again, doing it is fairly easy, but the mistake people have a tendency to make is to work too fast or to not write down all the steps. People say, oh, 50 is 25 and 2, I don't have to think about that, so then they put the 5 under the square root and the 2 outside. They do 2 root 5 instead of 5 root 2. And yeah, you got the right numbers in your mind, but you're not getting them down on the paper correctly. You're more likely to get them down on the paper correctly if you slow down and write out your steps. You just are. So it's not about giving you extra work, it's about making sure you do it correctly. All right, how are we going to set this one up? What theorem are we going to use? Okay, what theorem are we going to use for this? It's solve the triangle. Oh, I should probably mention this is the right triangle. That might help. What's the theorem we've been doing the entire chapter? Pythagorean theorem, which we would, how would we set this one up? Yep. Now we do have to be careful with these. Too many people just go 10 squared plus 16 squared. They take whatever two numbers are and they throw them in first. Don't do that. Don't be that person. Right? Stop and think before you start writing down. Slow yourself down just a little bit. And then it's not too tough. So subtracting 100, x squared is 156. So x is the square root of 156. Not a perfect square. We do have to simplify it, because we're going to put things in simplest radical form unless told to do so otherwise. So now we got to figure out what perfect square goes into 156. Well, half of 156 is 78. So we're going to start with numbers less than 78, perfect squares. The first one less than 78 is 64. Does 64 go evenly into 156? No. 49? No. How about 36? Nope. Okay. 25 clearly does not. 16? So it looks promising, but no, because 16 times 10 is 160, so 16 times 9, that's pretty close. So no, 16 doesn't work. 9? No, because 1 plus 5, oh no, 9 does go in. 1 plus 5 plus 6 is 12. Oh, no, it doesn't go in. 3 would go into that, but 9 does not. 9 does not go into 12, so 9 does not go into 156. So we're down to 4. 39 times. That's better. And root 4 is 2. So that's the length, oops, over there, of that side. Okay? So again, setting up and solving Pythagorean theorem. And again, as you're doing your work, show as much work as possible, especially on the quiz. Because if I see that you've set it up correctly, that's like a point, as a 3-point problem, and you show me just that you set it up correctly, well, you're going to get at least 1 point then. And if you got to x equals the square root of 156 right here, and you have that written down, now you're probably at 2 out of 3 points. At least. If you make a mistake simplifying it, you still got 2 out of 3. But if all I see written down is an answer and I get 4 root 39 instead of 2 root 39, but no work to support it, you're not going to get any points, even though you probably did it all right in your head. I can't score what's in your head. I can only score what's on the paper. It's a fact. You don't want me messing around inside your head and looking there to see what's going on. So that's the solution for that. We're just going to let the machine take that. Is this triangle acute, right, or obtuse? That's a question we need to ask ourselves. First off, you might be wondering what's the longest side, 11 or 6 root 5. But I can tell you that root 5 is bigger than 2, right? And 6 times 2 is 12, so that's already bigger than 11, so 6 root 5 has to be my longest side, doesn't it? If you weren't sure, you could decimalize it for a moment in your calculator just to check it. Either way, that's the third side. Now, once we've got that, what do we do? How are we going to set this up? (11 squared plus 8 squared) not equals. We're just going to compare to 6 root 5 squared. Now the 11 squared is easy, that's 121. The 8 squared is easy, that's 64. So if I add those together, that gives me 185. 6 root 5 squared is going to be a little bit more work. But again, that's just 6 squared times the square root of 5 squared. 6 squared is 36. Square root of 5 squared is 5. 36 times 5 is 180. Oh dear, and now here's where it comes in. They aren't equal. If it's equal, it's nice because it's the right triangle. They aren't equal. Now I have to decide, is it acute or obtuse? And remember, what we look at is the c squared, the one that's by itself. Is this too big? Is that too small? Or is that just right? The 180 is a little bit too small, isn't it? And small is what kind of angle? A small acute or obtuse? Small, yeah, because an acute angle is a small angle. It's too small, it's acute. This triangle is acute. Okay? It's close to being right, but not quite. And again, the big thing to remember with these is to remember it's this number, the c squared. Is that too big, too small, or acute? Not the sum too big, too small, the c squared, the one that's by itself. Is that the one that's too big, too small, or just right? Well, as you're checking the correct one, it's really simple. This is an interesting problem. You're going to see something like this in your worksheet on the test. It says, find the area of the triangle round to 2 decimal places. Notice this little bit of the instruction. That means now we're going to do decimal approximation, or doesn't it? So we're going to decimalize as we work. That's okay, because the instruction tells us to, and we can work that way. All right, in order to find the area of a triangle, we need that formula, base times height divided by 2. Should use a lowercase b. Again, for reasons that will become apparent later in the semester. I know the height. The height is 7. Something times 7 over 2. But I don't know the base, because the base would be the whole side. That whole thing. I only know that little 4 portion. Can I find the other portion? Well, altitude by definition forms a right angle, so if I solve this triangle, find all 3 sides. I know 2 sides. Can I find the third? How do I do it? We'll call it n. 7 squared plus n squared equals 11 squared. So 49. Doing that fun thing with the highlighter again. 49 plus n squared is 121. So n squared is 72. So n is the square root of 72. Now, I'm lucky. I can do what? I round to do decimal places here. So we can go ahead and use our calculator to approximate, because the instruction says to. So I just take my calculator, square root of 72. Square root of 72. Yeah, 8.49. There we are. And so my total length here, my total base is 4 plus 8.49, or 12.49. Everybody with me on that? See where that came from? Make sense? Yes? Okay. And now we just do our calculator. 12.49 times 7 divided by 2. 43.72. That's my area. I found the area of the triangle. The other thing people have a tendency to forget area with a triangle, they forget to divide by 2 bit. They do base times height, and they forget to divide by 2. You have to divide by 2. Base times height is a rectangle. A triangle is half of a rectangle, or half a parallelogram. So
If they give you like units, like inches and feet.
that'd be inches squared. Yep. And give you feet, it'd be like feet squared. If they don't give you one, if you don't like U for units, and you just want to, if they don't give you a unit, you just want to use inches or centimeters, that's fine. You can put centimeters squared or inches squared or whatever you like, if none is otherwise specified. I just use U for units to be generic. That's all. That's really it. Those are the types of questions you're going to have in your test. That's it. Should not be too tough, but you are going to have to take some care. So, I give you your ever-exciting worksheet, and I give you some time to work on it. We're out of here at what, 08? So you got more than 10 minutes. Now, you don't have to work on this sitting all by your lonesome. If you want to work with somebody else, and I mean, you're actually working with them, not just goofing around. As long as you're actually working with somebody else, I am fine with that. Now's a good time. If you have questions, by all means ask.